Okay, so we've just covered eastings and northings, and this is just the beginning of geolocation. There's a lot more after this, but I just want to, now is a good time to talk about one of the possible issues you might face if you're on Revit 2020. So on Revit 2020, you'll see I've got the exact same thing set up. You can ignore the rotation for now. And if I press, come on, here we go. If I press export on a Revit 2020 model, you can see it's still IFC4, and it's called IFC Project 1. And if I load that in, and if I go over to the geometry, georeferencing, you'll see that it looks correct, but you'll see two things which are different. The first is that you'll see that this says meters, but whereas the previous one gave it in meters in 20 and 10, this one gives it using the Revit project units. In this case, it's millimeters, so it's 20,000 and 10,000. This is a bug in Revit 2020. It's been fixed in 21 and above. So if you're in 2020, just keep in mind that that is one of the bugs which you will face. Another bug you're going to face is that when this says meters, it's actually not meters. It looks like meters. It says it's meters. Under the hood, if you open up this project one and you take a look at, sorry if this might look a little bit strange, we're going to take a look at the projected CRS, and the unit defined for this EPSG code is defined as a conversion-based unit called a meter, but it's actually defined as a meter multiplied by 0.3. It thinks a foot is a meter, so Revit gets a little bit confused. So it might look correct to you, but under the hood, the IFC data is actually incorrect in two ways. One, wrong numbers here, and two, wrong unit over there. But as long as you're on 21 and above, no problem. You should not have that issue.
But if you are stuck with the 2020 version, how do you undergo this? How do you fix this?
If your project units was meters in Revit, you would fix one out of the two issues. You would fix this issue, but you would not fix this issue. If you're in the US, you probably wouldn't have this issue. It would probably do it correctly. I haven't tested for the US, but it's the US. So if we take a look at outside the US, which deals with sensible units, then you'll probably have this issue. I did think of creating a patch for it, but just...
You are not paid to do that. Yes, I understand.
Yeah, it's fixed in 2021.
Yeah, so it's always a question whether it is a new functionality or really a bug fix. And our IFC team is doing a great job with really providing the newest feature to the latest two versions. So what we always recommend, I know this is not an ideal situation, but what we do recommend is to upgrade the model if you can, at least for the IFC export. Obviously, for the big projects, it's not always as easy. I'm also working currently on a workflow how you could maybe upgrade the model through the cloud, because our cloud can upgrade the model in the background and then also export the IFC with the newest IFC exporters and features and functions. So that's maybe also another thing to keep in mind about the possible ways and solutions. And I also noticed one thing, Dion, maybe this is not relevant, but I noticed you are exporting an IFC4 design transfer view before. I'm not sure if it was in this case, but the development is currently focused on the IFC4 reference view, because that's the one being actively developed by the Building Smart and the one which is also being certified. From what I know, the development of the design transfer view is a little bit of sleeping on the Building Smart side already. So they are more working on the IFC 4.3 and the new model view definitions, or IDS, or how they are called now. So it's a little bit of a question. I do understand that probably with the design transfer view, you get a better quality in the Blender BIM, because you want to change the geometry. You want really to read the geometry in a way that it becomes native. But from a development point of view, it is not the latest development, let's say so.
Correct. We covered that in our first video. You're absolutely right. We are using Design Transfer View on purpose in this video. And there are a few reasons why we do that. And we explain what the differences are. So we talked a little bit in our first video on one of the most obvious differences with being the material layer sets, which are parametric, versus the non-parametric geometry, which you just alluded to in the more native IFC geometry editing. Our particular topic today on georeferencing, it shouldn't make any difference which IFC4 MVD that you're using, but that's an absolutely great point to make out, that the development focus by Autodesk is focused more on the reference view. It still doesn't change my personal opinion on which one we should be using, which I think, but it's very good to mention where Autodesk's priorities currently lie.
But at the same time, if I understand this correctly, what Leila said, we are going to get better exports to IFC 4.3 because there is more focused on that as well?
Well, currently Revit supports IFC4. 4.3 is just currently being released and it's still not being certified. So we will have IFC 4.3 support soon in Revit, but that one is more focused on the civil and the infrastructure. And I think there has already been released a plugin for civil 3D, where it's obviously more relevant. And as mentioned, we are expecting an update for Revit as well. But I think that also doesn't make a big difference for the geolocation. So the issues or the topic will still stay the same. Maybe just to add one thing, it's not like our decision not to focus on the design transfer view. I do understand that the concept behind the design transfer view is a lot smarter in certain points, but it's also not being certified or actively developed at the moment by the Building Smart. So all the software vendors are currently actually forced to work on the model view definitions, which are currently certified, and that's the reference view. And for IFC 4.3, I guess there will be new ones. So the certification won't happen that soon for IFC 4.3.
Yeah, that makes absolute sense. Our series talks a little bit more about IFC as a native data schema rather than an exchange format. So that's why we break away from the concept of MVD in this series. But absolutely, for those who are using it purely as an exchange format, then by all means, the reference view would probably be the most stable bet. Absolutely. Okay, now that we've got eastings and northings set up and we're aware of some of the pitfalls in 2020, we'll take a look at the rotation. So you'll typically say to your surveyor, hey, tell me where north is, and he'll give you a number. He might give it to you in degrees, minutes, seconds, or in decimal degrees, doesn't matter. You'll type that in. You can visually check that that's roughly in the right spot, and then you'll press the export button and say that a job is well done. So now let's see what actually happens once it's in IFC. And this is an interesting bit. In IFC actually doesn't store that number we just typed in as 30 degrees. IFC stores it using two numbers called the x-axis abscissa and x-axis ordinate. Now, that's just a fancy way of giving a vector. If you think of this as the x-coordinate of a vector and a y-coordinate of a vector, so you can think of 0.8 out here and then 0.5 in, sorry, I can't read, 5 that way, negative side. That gives you a vector which should correlate to 30 degrees. And that's why you can see the derived angle is there. And the reason why it's important to mention this is because some tools don't tell you this derived angle, they will tell you this abscissa and ordinate directly. And it's important to know that they are actually the same thing. So for example, in ArchiCAD will show you an abscissa and ordinate. So it's not that a mistake has been made. You can see the angle is there, is correct. And in Blender, we can also verify that visually. If I set the Blender north and I just display, where does it show north? So you can see that north is over there, which matches where Revit says north is. And that's a great thing. So Revit has done the job and it should just work out of the box with no problem. Just be aware that there's a little bit of a different terminology that you might come across in different software. I guess we can also put it in the comments or the video description, the equation used to calculate this. It's basically sine and cos for those who really want to double check those numbers. Now, you'll notice that so far, I've been very hesitant on saying what type of north. In the past, I've been very clear that up here is project north. However, so far, I've just been calling this north. And the reason is because I want to highlight that this is a very common misunderstanding. In Revit, they call this true north. But the angle that your surveyor tells you is actually not true north. So this is actually misnamed in Revit. The true intention of what the surveyor is telling you is something a little bit different, known as, grid north. And basically, if you took the coordinate system that the coordinate reference system that the surveyor is using, such as this EPSG 7856, what is that up the page? So if you imagine a surveyor giving you a DWG in this coordinate system, and every point in that DWG is an easting and northing, up the page, not project north, like that up the page, is what a surveyor calls grid north, not true north. However, that's the same number you enter in here. And very often Revit users will link in a survey into their Revit model. And some surveyors will show you multiple norths on their drawing, a true north and a grid north. It's important that you always set to grid north and not true north. And the reason is because they're not the same. There's two different norths out there. Project north is just an arbitrary convention defined by the architect so that the design looks straight in the head, and that's fine. But when it comes to the real world, grid north is up the coordinate reference system, whereas true north is also known as geodetic north, points straight up to the North Pole. So for example, if an architect wanted to do a solar study, he should be using true north because that's how the sun works, in relation to true north. Whereas if an architect wanted to get their Revit settings right and their IFC settings right to coordinate across eastings and northings of a surveyor, he should be using grid north. And we can actually visualize this difference. So here I am in free software for GIS called QGIS. And currently I'm in EPSG 28356, which is the older Australian coordinate system. And I've drawn a perfectly straight line pointing up to grid north on the map. And you can just kind of trust me, it's straight. You can see it looks straight there. But if you don't trust me, you do your own exercise and you can figure this out. And now what happens if I change it to a different coordinate system, the same one that Google Maps uses, where it points up to true north? And if I change it, you'll see that that line has actually, it's no longer orthogonal. There is actually a slight degree difference. And it's not just a slight degree difference. Actually, true north is not a constant. That true north is calculated at a particular easting and northing. And so this line, which looks like a straight line, is actually a curve. It's so subtle, but it's just important to notice that it's actually not a straight line and it's not a constant. There's no real thing as a true, you shouldn't be putting a true north in Revit. So whenever you see Revit saying true north here, just mentally replace it with the word grid north. I hope that little explanation makes some sense, and it's a very common issue that I've come across on projects.
BIM people are not so interested about these details, but it's very nice that who is interested to look and to understand how things are working behind. Yeah, it's a very good explanation.
Absolutely. I think the problem is really that the Earth is not flat. So, we always have these curves and so on. I was just thinking about, true north for me as an architect. I think true north, okay, I know what it is because it's for me as an architect, there is one north. And I'm just not sure how many architects or structural engineers or people for who the Revit is actually also the intended tool really know about what the grid north is and really know the difference. So
that's right. And this is why it's a common misunderstanding. And I guess all architects and all the people doing vertical construction need to be aware of is that when you ring up your surveyor, you say, hey, Mr. Surveyor, what's the coordinate reference system? Tell me the EPSG code. Also tell me grid north. That's all you've got to mention, and make sure you get it down in writing. The last thing you want to be doing as an architect is writing down, as I just did, manually these numbers. Yeah. You should be getting from your surveyor all this stuff already done in a survey drawing, as well as what I call a site drawing. So I actually differentiate between the two. I say you should ask for two things from your surveyor. You should say, can I please have a site survey, which is the way surveyors see the world in eastings and northings and grid north up the page. And then you should say, can you also give me that DWG, DXF, whatever it is, as a site drawing? And I want you to transform it to small coordinates. I want you to do the rotation so that project north is up the page. The architect should not be responsible for doing that, but they should have that awareness to ask the surveyor as their responsibility. And they should have all those numbers down in writing at the beginning in a clear correspondence. Here are all the numerical values that can be checked. And later on, when we talk about dropping things into Revit rather than starting from Revit, everything should just work. And there should never be any manual rotations happening in Revit, never be any manual data input into Revit or IFC for that matter. It should just be correct because the surveyor has done their job correctly.
I absolutely agree on that. And maybe one thing to add is please do this at the beginning of the project. We often have these cases, when the architect says, look, I have already started the building, it's half ready, and now I need to align it with the others working on the project, with the surveyor and so on. And that gets really complicated.
It's a mess.
But I guess the architect doesn't need to know the answers, but he needs to be aware that there's more to it. And there's a reason why surveyors get trained to do what they do. So if an architect sees the true north value in there, he should be aware that if he loads up a surveyor's DWG and he's got two north, something architects like to check on the DWG, which one should he follow? Follow the grid north. He should also know that he shouldn't use this number for solar studies. He should use a slightly different number for solar studies. And he can ask that from the surveyor. He can say, hey, can you give me the true north sampled at this easting and northing? And, for a small site, Bob's renovation of his backyard, no problem. Who cares? The sun's here, there, yeah, whatever. But on especially larger projects, where you got spread across a campus or a large site, it starts to matter, especially for an architect doing solar studies. So it's just something to be aware of. So I guess that's one of the things in Revit that was good to mention, that there's this ongoing bug that Revit does not differentiate between grid north and true north. Just be aware of that. And the thing is that IFC does differentiate between grid north and true north. There is actually a place in IFC to store the true north, and you can see that over here. You can see that this is the grid north and this is the true north. But because in Revit doesn't distinguish between them, it will always give you the exact same value. You can see they're identical. So from a surveying perspective, this is incorrect data. From an IFC perspective, this is also incorrect data. But if you're going to get one of the two correct, because you can't get both correct, this is the one to get correct, because that's the one you're going to build on. This one, your solar study's a bit off. The shadow arrives 10 minutes after, when it's less of a problem. Okay, so hopefully that's one of the issues we've talked about. We've now covered on the rotation. I just want to mention that that's not all. There's actually this next step, which is also missed. I kind of see there being a number of common misconceptions around geolocation. And some people are aware of the true north and the grid north difference. The last one is something that very few people are aware of, but it's also vital in how surveying works and how IFC works. And this is known as the scale attribute. And you know how earlier on I showed you that bug, how Revit called it a meter, but in fact it wasn't a meter? Now, imagine that bug was fixed, and this is a meter. This meter isn't the meter that you learn in high school. When you learn about meters in high school, you take a tape measure and you go, plonk, here's a meter on the ground. That's 1 meter. However, this meter here, they call it a meter, but it's actually not the same SI meter that you're learning in high school. And that comes as a surprise to many people. It's actually not identical. So to differentiate the two, I'm going to call this a map meter, not a tape measure meter or a surface meter. And sometimes the term people use to distinguish this is the difference between a surface distance, which is what you get when you stick a tape measure on the ground, and a grid distance, which is what this coordinate reference system grid uses as a meter. And to give you an idea of that, if you go back onto our earlier example of something like Google Maps or OpenStreetMaps, they use a coordinate reference system. It uses meters. Like if I open up my GIS software, I'm already in it. So you can see that this is using a length unit of meters. It's not actually a real meter. It's a fake surveying meter. Of course, for a surveyor, it's a real surveying meter, but for us, it's a fake surveying meter. And in fact, for example, you go up north, that meter, the meters actually get closer together. So it's not a real meter. And what that means is that there is a conversion factor from the distances that these eastings and northings are measured in, these map meters, and the SI meters that architects and engineers use on vertical construction projects. So in vertical construction projects, typically you'll have a grid, and you'll say this grid to grid is, say, 10 meters apart, and you're expecting that somebody can whack out a tape measure and measure 10 meters apart. You shouldn't say that it's 10 map meters away. You shouldn't say that if the easting of one grid is 20, the easting of the next grid is 30. That's not quite right. There is actually a slight difference between the two. And the difference is, again, like I said, the true north is a curve and it's not a constant. This scale factor is also not a constant. It varies on every single easting and northing on the site. That scale conversion between the architect's grid to grid distance, if I go into Revit and I want to say this is the distance between this and that of 6.4 meters, it's different depending on where I am. So for a small site, the good news is that for a small site, for a vertical construction project, that scale factor between this distance, I'll call this the tape measure distance. That's an ugly number. Let's put that back over here. Actually, what I'll do is I'll draw a new wall, and we'll make that exactly 5 meters. So if I say this is 5 SI meters, and if I go into Revit and I go into having a mental blank here, it says spot coordinate. Here we are. Okay, those are not very nice numbers, but you'll get the idea. You can see that this plus that equals this. That's actually incorrect. There is actually a scale factor to be applied. They're meant to be slightly different. So the third thing you have to ask your surveyor is, what is the combined scale factor for my site? Because on a small site, even though the scale factor changes, it can be approximated to a constant. And when I say small site, the small site is defined by the Building Smart georeference experts as 1 kilometer. So if your site goes past 1 kilometer, then it's no longer considered small, and you cannot approximate that scale factor to be a constant. And whereas if you are dealing with a small site, you will get a constant. Now the problem is that, let's say the surveyor tells you that scale factor. Where do you put it in Revit? There's nowhere to put it in here. And so to do that, you'll need to go and add a new project parameter. Firstly, download the shared parameter provided by Autodesk. There's a link we'll provide in the description on where to get that. You press add, you go into shared parameters, and in the big list, go under project global positioning, and the one you're looking for is scale. So you'll add that, you can assign it to your project information, instance is fine, put it under IFC parameters, okay, in project information, here you go, and you enter in what the surveyor will tell you. In Australia, this will be a number that is not quite 1. It's very close to 1, but it's not quite. So for example, you might get a number back from the surveyor that is something like that. And so you'll enter that in. And if we export that now, and we load that back in, you can see that our scale has now appeared after the rotation. And we can show this. We can show the impact this has on the measurements. So if we take an input coordinate of 0, 0, 0 in our local engineering coordinate system, and we translate that to a global coordinate, well, it's simple. From the origin to a global coordinate, you add the eastings and northings, so you get 20 meters and 10 meters. That makes sense. Now, just to simplify things, I'm going to remove the rotation so we can think easily. If I want to convert 10 meters, I'm not going to get an easting of 30 meters. You'll see I've lost 0.5 of a millimeter due to that scale factor. And so what that means is that 10 meters away from my origin, if I want to see what the easting of that point is, I am now 0.5 of a millimeter out. And that's nothing. You know, if you have a small project, you can absorb these inaccuracies in your georeferencing easily. The problem comes when you have a larger project. So for example, you've got a 200 meter long project, you're going to start getting a much bigger deviation or inaccuracy. You could get 2 centimeters off, for example, or 15 mil off. And it also therefore means that you should be very wise in choosing where your false origin is. You know, if you're doing a train station, for example, and it's a few hundred meters from end to end with buffer on either end, don't choose your false origin to be at one far end of the project, because by the time that you move to the other end, if anybody on Revit is using the eastings and northing tools, they're going to get a wrong number. And so that's another thing I want to highlight, because Revit does not support the concept of a combined scale factor, that if your project uses this combined scale factor and you're an architect working in local engineering coordinates, if you use this tool, you will actually get incorrect numbers. Sorry, I'm using the wrong tool. So you cannot trust these numbers. This is the third one, which often I get a lot of questions about, but hopefully this helps address it. Just the fact that the map meter is not the same as the surface meter that we're used to. And it doesn't matter if you're in the US and using feet, the grid distance is not the same as the surface distance. I'll give you one practical example. Let's say you're working on a project with a large site, like a campus or a military base or something. You know, there's many spread apart buildings, is what I'm trying to get at. The surveyor gives you a DWG, it's got eastings and northings all over it. And the moment somebody presses the link WG in Revit and just tosses that in, he has already made a mistake, because he's assuming that that's local engineering. He doesn't realize very often that it's eastings and northings, and it's not the same as XY meter measurements. And what happens is that, unfortunately, this project setup and checking of set out sometimes in architectural firms can happen in people who aren't trained in this stuff. And so they'll go around, on one hand, they'll have AutoCAD looking at things, and then the other hand, they'll have a spot coordinate tool, and they can come to very incorrect conclusions across a large site. Mm-hmm. And so it's always good, just like if they come away from this video saying, you know, I didn't understand, it was interesting, but I didn't quite understand it, and that's fine. As long as you get that it's a little trickier than it seems to be, there is actually a combined scale factor involved. Always ask the surveyor in doubt. If you're ever going to try and do any sanity checks as an architect, maybe it's a good idea to ring up the surveyor and share your screen while you're at it.
Yeah. Maybe just to add my one thought, that's also the reason why we have the building tolerances, right? So like you say, 0.5 millimeter, so the site will never be that exact. So the construction on site will always vary a bit. That's why we usually don't worry about it, because the tolerances are there not only to cover the fact that the earth is not flat, but also the fact that we are not able to build that precise on site anyway.
Correct. So there's really two issues here. One is tolerance, which until you're really hitting that 20 mil mark when you've got a 300 meter long site, that's when you start encroaching on the concrete thing. And it also depends if you're doing a modular, with steel, modular across a long site. That's another issue with buildings. Smart likes to give as an example where this becomes a real problem. Otherwise, you're right, it does get absorbed. But there's another reason why this is important. It's important for people to at least realize, sure, if you just want to put your blinkers on and use the survey, spot coordinate tool and get it roughly correct, that's fine. But at least if you record this, there's a clear definition of the coordinate system that's being used. Is this a local system, or is this one-to-one, the eastings and northings like they would do on a civil project? And just the ability to record that precisely and take it down by the surveyor is, in my opinion, a very valuable thing to do. And if you're not a surveyor, hold the surveyor accountable. Ring them up, ask them for these values. One thing they might actually tell you is hey, we just approximated the scale to 1. So be it. Let them put it down in writing, enter it in as 1, and you have it on the project record. Everybody knows you're faking it slightly and get absorbed in the project tolerance if it's a small project, but at least you've done your due diligence in getting georeferencing absolutely correct.
All right. That makes sense, Dan.
So I guess the summary is, at the very beginning of the project, get your architect, surveyor, and a third party who will sanity check both of you in one room together and ask them projected CRSS name, get the EPSG code, eastings, northings, the angle of rotation, get it in a few different variants, DMS, DD. If you're really geeky, you can do the conversion to abscissant ordinate, the combined scale factor, and then ask for a site survey and a site drawing. The difference between the two is that the site survey is in eastings and northings, and then the site drawing has the false origin already applied and it's already rotated to project north and has any scale already done to it. So that way it's all set up already for you. And if you link that into Revit, it will look perfect.
Amazing.
Does that kind of make sense? The kind of 10 things you got to ask your surveyor?
Yes. Thank you for joining us, Leila.
Thank you for having me. It was really very interesting and I learned a lot. Thanks.